Today our topic is sine, cosine, and tangent ratio. So our learning target is how can I use the sine, cosine, and tangent ratios in a right triangle. So again, we're still focused on those right triangles. Vocabulary. A trigonometric ratio. Trigonometric. It's kind of a big word. We abbreviate it trig ratio. And it's the ratio of the length of two sides in a right triangle. We have three different ratios. Our sine ratio, which is abbreviated SIN, but we do pronounce it sine, not sin, so sine. And the sine of angle A is the opposite side over the hypotenuse. So hypotenuse is always across from your right angle, and then angle A right here, your opposite side is directly across from it. So it'd be the length of the opposite side over the length of the hypotenuse. Cosine, which is abbreviated COS, so cosine, is the ratio there is the adjacent side. So adjacent. Which means right next to. So it's the side that touches the angle, and then the hypotenuse, which again is across from your right angle. Then we have our tangent ratio, which is abbreviated as tan, T-A-N. And that does not use the hypotenuse at all. It just uses your opposite side and your adjacent side. So it's the opposite over adjacent. So now, if you're kind of looking at this, how am I supposed to remember which one is which? We have a cool little acronym called SOHCAHTOA. SOHCAHTOA. So it breaks up your different ratios. We have our sine ratio. So sine for S is opposite over hypotenuse. So that's the SO piece. Ca is your cosine. So it's got C-A-H. So cosine for C, and then adjacent over hypotenuse. And then TOA is your tangent ratio, and it's the opposite over adjacent. So SOHCAHTOA, I would memorize that, use it. You're going to need it for the rest of your high school math career. So SOHCAHTOA is going to keep coming up. All right, so some examples. Find the tangent of angle J. So tangent of angle J, so let's find angle J. First, let's label our sides. Hypotenuse, always across from the right angle. Opposite of J, so we're going to draw that line across. This is our opposite. And then the side right next to the angle right here is your adjacent. Tangent, TOA. Tangent is opposite over adjacent. So tangent of J would equal our opposite side, 24, over our adjacent side, 32. Reduce, and we would get 3 over 4. That's your tangent of J. Example 2, find the value of X. All right, so now we're given the angle measure, 32 degrees, but we don't know one of our side lengths. So again, let's first start by labeling our sides. Hypotenuse, directly across from that right angle. We're looking at angle 32. Opposite would be 11. And our adjacent would be X, the one right next to the angle. Now, we know opposite and adjacent, which means we're going to be using a tangent ratio because tangent of an angle equals your opposite side over your adjacent side. So let's just fill in the blanks. Tangent of the angle is 32 degrees equals the opposite side, 11, over the adjacent side, X. Now we want to get X all by itself, so we're going to have to do a little algebra here. First off, we need to get X out of the denominator, so we're going to multiply by X on both sides. So now we have X times the tangent of 32 degrees equals 11. Well, now we want x all by itself, so we have to undo this multiplication with division. We're going to divide by the tangent of 32 degrees on both sides. Tangent of 32 degrees is going to cross out, so x equals 11 over the tangent of 32 degrees. Now, we want to actually solve for that, get a number. So we're going to have to use our calculator. You are going to need a scientific calculator, and we're going to actually be using our sin, cos, and tan keys. So they mean sine, cosine, and tangent. So those keys right there, up above your parentheses, so 2 spaces above your numbers, we're going to be using those keys. The first thing, however, is we do need to make sure our calculator is set up correctly. So we're going to go to mode, and right here, we want it to be highlighted on degree. So we don't want this radian function, we want degree because we're working with 32 degrees. So our calculator needs to be in degrees. So we're going to scroll down to where it's flashing on radian. We're going to scroll over so it's flashing on degree and hit enter. Now we're good to go. To get out of here, we can just hit clear. So now we're in the correct mode. And now all we have to do is type this in. So we do 11 divided by the tangent right there of 32. Close that parentheses and hit enter. And we get 17.60367982. We do want to round, and our rule of thumb will be we'll round to the nearest tenth. So we'll say x equals 17.6. So right here, x equals 17.6. Next example on the back of your page. Now we're using a sine ratio, sine. So we're thinking SOHCAHTOA. We're using that first piece. So we're using opposite over hypotenuse. So we need to label our sides. Hypotenuse is directly across from that right angle. So 17 is our hypotenuse. We're looking at angle x. So if we look at x right here, opposite all the way across here is going to be 8. So our sine of x equals opposite 8 over hypotenuse 17. Now, some of you guys might be like, what are these ratios going to be useful for? And these ratios are really helpful for when our next chapter, we're going to be talking about how to actually find the angle measure of x. So if all you know is that you have a right triangle and the side lengths, you can actually determine the angle of x by these ratios. So that's where they're going to come into play. But first off, we have to just get used to writing out these ratios. Next example, we need our cosine of r. So again, let's think about SOHCAHTOA. We're using cosine, so we're in this middle chunk, adjacent over hypotenuse. So let's label our sides hypotenuse directly across from our right angle. Oh no, we don't know what it is. Thankfully, we have a theorem that helps us find it. Pythagorean theorem. Right triangle means we can use a squared plus b squared equals c squared. C squared would be our hypotenuse. We know our legs, 9 and 12, so 9 squared plus 12 squared equals c squared. Not quite sure what that is. 9 squared is 81. I'll continue my work down here. Plus 12 squared is 144 equals c squared. 81 plus 144 is 225, which equals c squared. Get c all by itself, take the square root of both sides, and we should get c equals 15. Now, we know our hypotenuse. Hypotenuse is 15. Now we need our other side, our adjacent side, and we're looking at angle r. So let's find angle r. Adjacent side is the side right next to it. That's not the hypotenuse, so it would be 9. So we can say the cosine of r equals 9 adjacent side over 15 hypotenuse. Simplify that to 3 over 5. Last example for you guys. Use a sine or cosine ratio to find the value of the variables. We're missing x and y. We know our angle measure is 32 degrees and we know our hypotenuse is 18. So let's start by setting up a sine ratio. Sine, so katoa, so we're at that beginning, so it's opposite over hypotenuse. So if we're looking for the sine of 32 degrees, our angle measure, opposite side would be x over hypotenuse 18. Get x by itself, we're going to multiply both sides by 18. 18's cancel, we're left with x equals 18 times the sine of 32 degrees. Our calculators are going to come in handy again. So we want to determine 18 times the sine of 32 degrees. Our calculator should already be in degrees, but if you want to check, you can make sure. Then 18 times our sine, so we're using our sine button. 32 goes in parentheses, press enter. We get a decimal answer. Remember, we want to round that to the nearest tenth. So we can say x equals 9.5. Now that we've solved for x, we can solve for y in a very similar fashion, except for now we're going to be using that cosine ratio. Cosine is adjacent over hypotenuse. 32 degrees, we're looking at this angle, so our adjacent side is the side right next to it, so y. So we can say our cosine of 32 degrees equals adjacent side y over hypotenuse, 18. Get y all by itself. Again, we're going to multiply by 18 on both sides. So we get 18 times the cosine of 32 degrees equals y. Now again, we're going back to our calculator. So we're going to evaluate 18 times the cosine, right there in the middle, of 32, close the parentheses, equals 15.26486573. We're going to round, so y equals 15.2, but then there's a 6 after that 2, which means we're going to round that 2 up to a 3. So y equals 15.3. All right, that is all the notes that I have for you today. Please remember to take your video notes quiz, your 9 or 7.6 video notes quiz. Get some practice in on this concept and then come to class with your questions. Thank you for watching this video and please subscribe to my YouTube channel.